Hello and welcome everyone. As you all know, any interaction with large language model means you are generating a text in a non-multimodal context. So you are sending a request to a large language model and it is obliged to generate some kind of text back and return you the response. So we actually do not like that kind of approach because we do not know if the large language model is hallucinating or not. So there have been several different approaches where we have tried to overcome such scenarios. One of those approaches is a React agent, where the agent has the capability of reasoning and then taking an action on top of it. But if we do that, we give a lot of control to the agent and to the large language model, where we believe that the large language model and the agent knows exactly when to stop and when to do what, which flows to follow, and dynamically choose certain conditions even without we wanting it to do that. So the way we overcome this React scenario is by creating our own graph. So we create a graph kind of environment for an agent where we say, hey, you can do these activities, you can utilize these particular tools, but then you have to follow this particular path that the user as a developer has generated for you. For example, in the last video, I've shown you how a user can ask a question will be taken as an input by the large language model, and then we'll be maintaining a state. And in the state, the initial question will be stored, any kind of tool response will be stored, any kind of agent response will be stored, and we'll also keep an eye on agent call count and tool call count, right? So how many times the tool was invoked, how many times the agent was invoked, and all that. And then we'll also have a second LLM interaction where we will force the large language model to reason whether the question that it has answered, picking it from the state, is correct or not, right? And we developed all this in the previous example using LangGraph. However, imagine if you had the whole way of visualizing how everything is happening. So I'll show you one of the code pieces that I have developed over here. It does not use LangGraph, LangChain, or any such concept. It is just showing you in very simple terms how you can write all this by yourself, and you can actually make it even more useful. So let me show you. In this example, you will see how we are executing a node, and while the node is being executed, it highlights it, and you can see the current state also. So not only you can see what the structure of the flow is, you can also do the conditional routing. You can define what functions and methods are going to be executed on each node, and you can visualize the exact state for every node, right? So in going back to that agent example that we had over here, this is the state. Imagine you are able to see and visualize the state while your application is running, which is what we have achieved in this state managed graph example over here. And I've chosen a name mGraph for this, and it's very simple to implement. The way to implement this is what I'll be showing you in this video. So if you go to GitHub, this is available on this particular repo, github.com teachings mGraph. And in this, I have certain branches. So the one that I'm going to show you today is this sample implementation branch, and I'll merge some of the changes back into the master branch, but this is where we are at right now since sample implementation. So once you switch to that branch and check out the code from there, you will see that you have two folders, an app folder and a graph folder, right? So the app folder is meant for the visual representation. So all the HTML, CSS, and JavaScript that you are seeing on the web page, right? So all these elements, they are in this app folder. On top of this, we also have the fast API router over here and the routes.py, where we have set up the WebSocket based communication, right? So we have opened up a WebSocket endpoint, and this is where the bidirectional communication happens, right? Which is what WebSockets is. WebSocket is a bidirectional communication protocol that allows you to do real-time low latency interactions between the client and the server. And the server endpoint is what we have defined in this particular routes.py. You do not have to ever mess with it or change it, but all I wanted to show you is that it is a very simple WebSockets implementation where we are just passing along the graph data, the state data, and whether the graph is completed or not, and a real-time communication is happening over here. Why WebSockets though? So WebSockets are used to establish this bidirectional communication channel, right? So between the client and the web server. And the server can send updates or the messages to the client in real time, which is reflected on the web page. So anytime when a node is processing, it highlights that particular node. So for example, we are on the end node right now. It highlights that particular node. And it also does the state synchronization, right? So whatever is the current state, it is synchronized and it is showing you exactly the data that is in the state at that time. So this is the purpose of your routes.py. You'll never have to change this. I'm going to just close this. But what you do have to change while you're setting up your own implementation are two files in the graph folder over here, right? So in the graph folder, there are 4 files: graph, states, nodes, and setup. You will not have to mess around with the graph.py. You will not have to mess around with the state.py, right? These two will be staying the way they are. The files that you have to change is nodes and setup in order for you to set up your own graph example. Okay, so let's see how I set up this graph example. So in this example, if you see, there is an initial node. The initial node is the setup node, right? So the setup node is where you define your state. So in this case, I'll just define all the nodes first over here, and then I'll show you how you put the data inside these nodes. So creation of nodes is very easy. You define your graph, right? You don't have to change that, but these are the 3 steps that you have to do, that you do have to change. So if you have certain number of nodes in your mind, for example, in this case, I had 1, 2, 3, 4, 5, 6. So setup and end being the 2 nodes that I always like to have, but 4 other nodes on top of it. So 2 plus 4, total of 6 nodes are over here. So I'll need 6 add node elements, right? So 6 of graph.add node elements, which is what you see over here. 1, 2, 3, 4, 5, 6. 6 graph.add node elements. And you have the name of that particular node, right? So the name of the node, like setup, A, B, C, D, and N. These are the name of the nodes that you will see as the first element. And the second element is the actual function that it is executing, right? So like whenever you are at a particular node in the flow, you want the certain action to be executed, right? That's why you are having a graph or a state managed flow. You want a state to be passed to a node, and you want a function to be executed in a node. So these are the 2 things that we are defining over here. We are defining, number 1, which nodes exist and what functions we want to execute. So we haven't defined these functions yet, but we will be soon defining it. But I just want to show you that these are the functions that will be executed. And these are the names of the nodes that we have. On the left hand side is the name of the node. On the right hand side is the function that we are trying to execute. So in our example, we have 6 nodes, and that is why we have 6 of graph.add nodes over here. And each node has its own function that we have to run. And we will define those functions in the nodes.py, but I'll keep that as the second file to explain. So please hold on for explanation on the functions that we have to define, right? So 6 nodes and 6 graph.add nodes. All right. Now we have to define the entry point. This is where the execution starts. So the entry point of the execution over here is setup. So we do graph.setEntryPoint setup, right? So this is the entry point over here. And then we define the routing. So in this case, we define the edges. So from setup, we are going to A. So setup to A. From A, we are going to B. So graph.add edge A to B, right? So it is from and to, right? So setup to A to B. Now you can see the pattern. From B we can go to C, and from B we can go to D, right? So there are two edges over here. So from B we can go to C, and from B we can go to D. So now the question you must be asking is that, hey, how do we know that whether we have to go from B to C or from B to D? And we will see that in the nodes.py, right? So over here we are just defining the graph, right? That, hey, this is a possibility and this is also a possibility over here, right? So from B to C and from B to D. And that is why we have defined B to C and B to D. And then we have both from C and D, we are then going to reach to an end over here, right? So that's why add edge C to end and D to end. So what I would do is I would draw out this particular graph first on piece of pen and paper, and then I'll create the nodes. I'll create an entry point, and then I'll add all the edges. And if you count, 1, 2, 3, 4, 5, 6 edges exist, and 1, 2, 3, 4, 5, 6 edges exist over here too, right? So this is very critical, that we can relate one-to-one every single element on this graph. You can relate one-to-one over here in this particular graph setup.py file over here, where you are setting up the graph. Right? So there are 3 steps to it. Again, just to summarize, step number 1 is to add a node corresponding to each node that you have over here. And you have to create a function that you want to execute in the node. And we'll talk about that in a second. So we haven't created the functions yet, but just as a summary, you have to create the node name and the function name. Right? And then you have to describe the entry point, whichever is the entry point. And then you have to describe what the edges are. And if there are any split edges where from B you can go to either C or D, just define that for now. From B you can go to either C or B to D. And how that conditional routing will happen, we will see in this nodes.py file, where we are also going to see the functions that are going to be executed in each node. All right, now is the time to go to nodes.py file. So once you have defined your graph and you are happy with how the graph looks like, let's go to nodes.py file. Okay, so in nodes.py file, we are defining that whenever we are at a particular node, what actually happens, right? So if you are at a setup node, you want to define the current state, then you can define the state over there. If you are at node A, if you want to do a LLM interaction and then you want to pull some data out of LLM interaction, you will do all that over here, update the state, and then you will go to step number B. And then you will just keep on going, continuing like that. Whatever actual business logic you want to run in each and every node is the function for that particular node, right? So in the setup.py, you have already said that for each node, you are associating a function to each node. And now in nodes.py, you are writing the actual business logic for that, right? So in nodes.py, for very first node underscore setup, you are writing the business logic over here. So in this case, all I have done is that, hey, in a state object, just update a key value pair called step and setup, right? So we have added a new variable called step and its value called setup to our state in the very first node over here. That's all that we are doing. So in this case, all I'm doing is I'm creating a state, and in that state, I'm creating a variable called step, and then I'm adding whichever step you are at. So at the very first time, we were at the setup step. So, excuse me. So we just updated the value as setup at that time. So if you see over here, step says end, that's because we are already at the very last point. But when we were at the setup state, the step would say setup as the state. Now we can choose to have anything in the state, right? So for example, we can choose to have the tool response, agent call count, whatever. And all we have to do is state.update tool underscore response, and we can update the tool response over here, right? So this is the key, the left hand side is the key and right hand side is the value. State.update would add a value if it does not exist and update the value if it already exists, right? So it will overwrite it. It will overwrite it if it exists, and it would update, it would add it if it does not exist, right? So up until this point, for the entry point node, which is the setup node, state does not exist. There is nothing in the state. So when we set state.update step setup, it actually created that value over there. And then down the line, at any point, if we say step as a new value, then instead of creating a new entry over here, it will just update this entry, right? So at the very first point, the value was setup, and at the very last point, the value was end. Before I continue, I will run this application again so that you can visualize this, right? So I'm going to run this application again, and I will reload this page, and just keep an eye on this particular thing once we are in the setup state. So you will see it said setup at the very first time, and then it executed and went forward, right? So I'm hitting enter, it said setup, and then it said A, and then it set step B, and then it is step C, and then it will say step end. So now you can make a correlation. When I'm explaining the code over here, you will be able to make this correlation that how this is happening. So now at the very first node, node setup, it was adding this attribute over here, and then it was executing any other business logic that we wanted to execute, we can execute. In my case, I'm just adding one attribute value over here, and that's it. Now, if we go to the next node, node A, so we define node A over here. We define that we just want to update the key step and the value A, right? So that is why when you were on the next step over here, it just updated the value as A for that. And one key thing you will notice is the return for any node, right? So any function over here, the return element determines where the flow is going, right? So if you have return A, setup is going to return A, means setup is returning to A. Node A is returning B, so A is going to B. Node B is returning either C or D, right? So there is a conditional logic over here, which is what I was talking about. So this conditional logic is what returns it to either C or D, right? And then from C or D, we are returning it to end. And so from D to end and from C to end, right? And that is where the end node execution step is done. And if you see, the only business logic that I have in this whole flow right now is that I am just updating the step value, right? So like in the very first node setup, this step key value pair did not exist, so it was created. But in any subsequent step, this key value pairs step key was already there, so it updated it to A or B or C or D or end, right? And when it reached end, you got the end over here. All right, and this is actually all that you need to do. So all you need to do is to modify only two different files. File 1 is the setup.py and file 2 is the nodes.py, and that's it. There is no other changes needed in this application. All of the files will stay exactly same, and you'll be able to set up your LangGraph kind of environment. And you'll be able to visualize where your nodes are going in and how each and every current state is being displayed. You'll be able to visualize that too. Now, all that being said, there is one thing I don't know if you guys have noticed over here. How is the control flow happening, right? So there is a control flow from setup. You're going to A, to B, to C or D, and then to end. So this control flow is happening only from the nodes.py. This is very important. The control flow is happening from nodes.py, which means that the execution of the step determines which the next node to go to. And which is obvious too, right? I mean, once you are at a particular step, you want to take an action on certain attributes and data elements, and based on that you want to determine which next node you want to go to. So the return element for any node determines what the next node should be, right? So from setup we are returning A, and A is the name for the node, right? So if you see nodes.py and setup.py are tightly coupled, right? So in setup.py you are defining these nodes, right? So A, B, C, D, end, and setup. And in nodes.py you are returning those node values A, B, C, D, or end, right? So whichever is the return from the particular node function is where you are routing your flow to. And this is very important, that we are not returning the state back, but we are returning the actual value of the node, the actual name of the node where we want to go to. So we are defining the name of the nodes in this particular setup.py, and then in the nodes.py we are defining where actually we want to go to which node, right? We are defining the function that we want to execute, and at the end of the function we are defining which node we want to go to. Now, if you have noticed, there is one thing that you might have seen, that hey, if these functions already define which next node to go to, in that case, why do we need to create edges, right? So this edges section is trivial. We don't need that. And that is actually accurate. We do not need that in reality, right? So let me go ahead and let me comment this out, and I will show you what I'm talking about. If you comment the whole creation of the edges part out, and if you only create, you know, the nodes over here, what happens? So let's see that. Let's see. So if we do this and if we rerun the application, so before commenting it out, the flow was setup A, B, C, and end, right? And you have this nice, beautiful graph view over here. And if we comment out the edges creation, and if we refresh this, you will see the similar flow happens: setup A, B, and then C, and it won't go to D, and it will go to end, right? So it did exactly the same thing. However, you don't see the graph. So in order for you to see the graph, you need to have that particular flow created over here, add graph.add edges created over here. If you do not care about the graph, then there is another thing that I have for you, right? If you do not care about visualizing the graph over here properly, then there is one more thing that we can do, which is what I want to show you as rungraph.py. So the app.py is something that starts up that WebSockets endpoint and does the communication with the HTML, and you can see on the fly how the execution is happening. But if you do not care about all that, if you don't want to spin up that web server, which is over here, I can exit that and get out of here, and you can just do this rungraph.py. So all you have to do is you just have to have this particular graph folder where you have graph.py, nodes.py, setup.py, and state.py, right? These 4 files you will need. And if you do run graph.py, let's do that. Python run graph.py. And if we do this, you will see that the same execution happens, right? You are in the execution step, then execution node A, then B, then C, and end. And you just do not have that visual representation of it. Okay, but still you are able to achieve exactly every single thing. You are able to have a state, you are able to have a flow that you have determined, but you are not able to visualize it. So I really like having this visual representation. So I will uncomment this, and I will always get this kind of visual representation while I'm working with it. But at the same time, I wanted you to know that this is optional. Creation of edges is optional, because the way routing is working over here, the way routing is working is via the nodes. So the return of each and every node is what guides the next node to go to. So return of the node is the next node's key. And this is how the conditional routing or the simple static routing is working in this framework, which makes it very easy. You do not have to think about, adding conditional edges and all that. No, you just have to send your return as the next element, and that's it. That's all that you have to do. So all this being said, let me add an element, and I want to show you like how would you add an element to your state, like how would that look like. So let me run this application again so I can show you over here. And because I have re-enabled the creation of the edges over here, you'll be able to see how this looks like. So let me hit enter over here and you can see this. So this is how the current execution is, right? So we are going from setup A, B, C, and then to end. And we are able to see the current state at every time, right? Let's say if we wanted to add another element, let's say name element, right? So we go to the node, and node, which is the setup node, we can add an element over here, right? So we can, let's just copy this and add another element called, let's say, name, and I'm just gonna put my name over here, Mukul, right? So now if I rerun this state again, so you will see that there are two elements in this. One is step and another is name. And step is being updated throughout while we are moving along, but the name is not, right? So name did not update at all. So let's change that. So if there was a business logic that if you reached C, edge C, then the last name would be added as let's see. So if you reached the node C, then last name is Tango, but if you, or let's say Smith, right? Smith. But if you reach the node D, then the last name is Tripathi, my real last name. And we will also put, no, not this. We'll take this and we will put the last name as empty to begin with, right? So you will see that in the state, now what we have is three elements: step, name, and last name. Step is setup, name is Mukul, and last name is empty to begin with. And let's do that. Let's rerun this graph and let's see. So setup, Mukul, and last name, and setup, step is A, B, and when we reach C, it changed my last name to Smith, and then it reached end. But if the flow was going from D to end, let's simulate that scenario. So let's do, if 2 is less than 1, right? So it will, instead of returning C, it will return D now because it will go into the else condition. So the node B is now going to route to D, and let's see what it does to the final state over here. Let's hit enter. So it goes to setup, A, B, takes the route D and changes the last name to Tripathi, and then to end over here. Perfect. So this is what I want to show you, that actual business logic that you're executing. In my case, I'm just updating the state, but over here, you could have potentially called an LLM, right? So you could have had an LLM interaction, and then you could have updated the details based on that, right? And this is what the state managed graph should do. You should be able to define what your initial state is. You should be able to take that state through each and every node, and then you can pick and choose which element of state do you want to actually update. So a very logical way of utilizing such a framework would be to store the LLM communication, right? So the system message, then user message, AI message, tool messages, and all that. And then you can just store that in a state. And then whenever you are in a particular node, right, you can recall the particular conversation, You can send it to chat completions API. You can get the response back, and then you can take some action on it. Or if you are in a step where you want to go to a particular news article to retrieve some data from Wikipedia to get some weather information, then you can do all that. You can do a Google search, Serper API on a particular node where you don't need an LLM interaction. You can do all that and then come back, merge in, and create your own state graph. So this is just an introduction to the mGraph framework that I have over here. And I've already published it. It is, in a very simplistic original state. Please give me a feedback how you guys like it, how you feel about it. And I'll be making some more videos on how it can be used as a drop-in replacement for LangGraph. Without any kind of LangGraph elements or structure in there. A very cool thing that I like about LangGraph is that you do not need to define your tool's schema, right? So you can just write @tool and it can extract the whole schema out of it, which is what I want to show you in the next video. So if you are here and if you wanna get a head start, that I have already published, that repo is already here. So Onllama native tool calling. This repo is already here, but I would go in in-depth detail and I would explain what is happening over here and how you can use a tool decorator to extract a function from a function definition from a tool and then utilize the mGraph framework that I'm showing you over here, a very simple mGraph framework to implement your structured state managed flow for the agentic communication. All right, thank you everyone for watching this video, and I will see you guys in the next one.